Hey, Rani here. Shall we make a game? So, last time we got this to the point at which it is indeed moving towards the targets that we're doing pathfinding, but we have a line of sight, we have our maze built, so now we need to find a path. So it's going to be a code heavy one again, just how it is, I suppose. So, yeah, we've got a list of all of the faces and the best distance we found to it. So our next step is we need to recurse over the whole thing and find the best route to the goal. So, yeah, how do we do that? Okay, I guess we always consider the first edge. Yep. And then, yeah, and we have a slightly different loop for the other edges because we are comparing them. Right, okay. That's simple enough. So we're going to have our neighbors. We're going to have our edge midpoint distances. We're going to have our face, and we have our destination face. Now, no, I can't do it like that because you might... I can't assume there's always going to be at least one triangle, it's like polygon you can move into. You could have a valid nav mesh of only one face in it. So let's instead loop as we would normally. So I'm going to create that but not initialize it. We're going to have our, we're going to have our output. Navigation result, no route. Okay. If, oh yeah, I wasn't quite sure I was going to have this return. Yeah. If it isn't not a number, I still need to come up with a better name for that. Isn't not a number. And we either haven't found the best route at all, or the distance we traveled to get there is smaller. That's when we set that to our output, reset to 0, and that's when we record that as our best distance. All right, okay. Now, we need to give it the distance to this point, so at this point, this is where we need to get that center point distance out. Where there it is. And okay, right. So now we need to get the next edge. Yes. And we're going to look at the neighbors. Where are neighbors? I need to start extracting things out of this navigation mesh so we can use them. Yeah, so we're going to need the neighbors. We're going to need the edge midpoint distances. That's the one. We need to get them in general though, and then we're going to have one for the starting face. Origin, neighbors, that'll do. All right, okay. Oh, hang on. I need to remove one of those. Yeah. What else do we need? We need the edge midpoint center distances. That name sucks so much. Can I write another const there? Well, let's see if the compiler complains about that. If it does, we'll remove it. I think we can get away with another one. Don't remember though. Yeah, I think we should be able to get away with that. I wish there was a way in C to say that everything is constant by default. Instead, you know, declare things to be non-constant. That'd be much more in line with what I actually want. What else do we have? Okay, yeah, we'll define that. Distances is going to be navigation mesh. Margin face. Okay, got it. Okay, yeah, so we're actually kind of draw what we're doing here. So we're in our kind of we're in our starting polygon. Hey, I used the right word for once. And let's say we had like a polygon over here and a polygon over here. We're going to go around them. We're going to go around all the edges and go, well, is there some way we can actually go that way? And if there is, we use the distance between here and here as a starting point, and from there, we can kind of like fan out into all the various directions it can go into. So, we just need to tell it which way we entered the face. So that's going to define how we actually, our cost for crossing the face. Man, I am exhausted again. Oh no. Not much more of this kind of streaming challenge thing to go, I guess, though. Okay, that's good. All right, that looks like that should work. And then we're going to do this bit up here where we basically then look at the neighbors of wherever we end up. And actually, first of all, we need to make sure the distance, make sure we haven't gotten to this, make sure we haven't gotten to this a bit sooner. Okay. Oh, we don't actually have the distances in here. That would help, wouldn't it? Oh no, we already have them. It's a static label, I forgot. I guess in theory I could put them on the stack in here. That would actually... Why don't I just do that? Yeah, I'll just do that. Why didn't I do that in the first place? Where's the function working in? Here it is. Okay, and then we then need to pass that into here, which is that. So let's look this up again because I've already forgotten how it works. It's a point where you can't change each other. Okay. It's that one I want. Okay, so the very first thing we need to do is have a look at the best distances, and if our distance is smaller than the best distance found here, then we actually consider what happens if we go somewhere else. So we then need to get the number of... Oh, I need to get the number of vertices in here actually as well. Okay. And there's actually a lot of data we're passing through. We're almost passing through the whole nav mesh. Let's put that in there too. And then Microsoft Teams opened for some reason. How do I make this go away? Hang on. Oh, and then it's just disappeared again. Fair enough. Oh no. Anyway, yeah. Back to my train of thought. What little of it remains. I don't know how many hours of productivity have been lost to things like that. When you get the number of edges by looking at the face. So now I've got the edge. Okay. And that face. And we've got the edge midpoint distances. So now we can kind of like narrow that down. Okay, that's good. Okay, and now we go over the edges and we're then going to calculate the kind of distance, the kind of like distance if we cross both. We're going to take the distance we've already traveled to get to this point, add the distance we're going to have to spend to cross the face to that particular edge, and kind of move on from there. So let's get the neighbors of this face. Where's the, there we go. So yeah, so now we know at this point it's not just a brick wall over that edge, so we can carry on. Face neighbors, that's what we want. And we then, hang on a second. Calculate the next distance. Let's say we could just do it by recursing now. Yeah, we could also have the best distance out of here as well. So it's important to set to kind of write back to that list of where we've been right at the start, so we don't sort of like repeatedly recurse back and forth between the two. Because otherwise, what we might end up doing is say going to here and then going, oh, never been to here. Oh, we've never been to here. Oh, we've never been to here. So we need to like mark it as kind of visited as soon as possible. We're using not a number, aren't we, to say that we couldn't find a route to it? Yeah, that's fine. That's fine. Okay. All right. Okay. And then we want to navigate again. So vertex count, neighbors, edge midpoint distances, best distances, and next face. The edge we're crossing to get to it. Oh, hang on a second. I've just spotted a bug. How am I going to solve this one? Right, so the problem is, let me explain this through the art of drawing. Right. So, let's say I've got this polygon here, right? And should I use the text? Oh, there isn't a text tool in this. Is there a text tool in this? Kind of feels like there should be one. Anyway, you got edge 0, edge 1, edge 2, edge 3. Right. Okay, now I cross into this polygon, right? Hunky-dory, no problem at all. The problem is I don't know which edge it is in this polygon, because it could be like this. Just because we crossed edge 1 on this side to get into here doesn't mean we're actually now in edge 2. So I'm just going to make a note. I need to fix that. To do, you need to provide the correct edge. So I might end up making a lookup table for that, as it's going to be something we're doing very often. I don't really want to be looping over all of these every time. We're already doing plenty of looping. To do, select correct edge. Now, generating the data for that and testing it is going to be it's going to be interesting. Not quite sure I'm going to do that yet. Edge midpoint distances, face edge midpoint distances, and going from our own edge to we should call this next edge so we're not getting them confused. So we're going for, actually we could probably, yeah, we could do this. Aha! Now we need to consider which edge we're going to. Took me a second. And yep, that's calculation done. So we now have the next distance, and we then check if that is, if it's not a number, which is still kind of hard to wrap my brain around. And it's closer than, oh, we're not actually tracking the best distance. And we've either not found the best distance or we're closer than it. Then that's our new best distance. Okay, and then we just need to define here our best distance, and it's going to be not a number. There it is. And then we just return that, and that's going to be our output from this. Okay, very good, very nice. Oh, that should be an or, not an and. Okay, so the next thing is we need that, that's implemented, except we need that lookup list of exactly which is the corresponding edge. So we've got the neighbor thing here. Okay, so we've got neighbor, edges, and faces. Okay. Oh, that's gonna hurt. It's gonna hurt. Okay. It's gonna be a lot of places I've just broken by doing that. It's gonna be a lot of code that has to be slightly rewritten. It's worth it though. It's worth it. It's clearer than the alternative would be. Okay, and I think the other part of it is going to be in object to C. Yeah. Getting there, getting there, getting there. My God, how many places is there write this? Okay. That's dealt with. Now, oh, helps if you type it correctly. Could be worse, I could have spelled feces. Doing the same thing but for edges rather than faces. Right, and to do, we need to, how many places have I written this? I'll just say it, okay. Calculate edges. Yeah, so we're keeping a track of which, I think we're keeping a track of which edge, oh, we know which edge we're over because we're looping. I need to reconsider this. I need to check whether this is still right. Ah! Okay, let's add the code that actually writes this out there. So we're gonna need. Yeah, we're gonna need to basically copy and paste this entire segment pretty much. Let's just keep checking. I think I've got some. Oh, I've still got tons of places we're still using the wrong term. Damn it. Is there going to be a lot in here? I don't think so. No, that looks clean. What do you have in here? Oh, okay, we got this. We got this. Ah, there we go. Okay, that's done. That's done. We're finally done with that. Oh. So now we need to write out the edge remappings, which should be okay. Yep. Of its neighbor edges. That's what. Yeah. Oh man, my head is just full of words. Okay, and there's one last thing. Ah, oh, damn it, I did it wrong. Did it wrong? Nope. Because we're writing remappings. Yeah, I want to keep both. I want to keep both these in here. Okay. Okay. All right. Next up, all we have to do is write them. Is just write them back out. That's not so difficult to do. He says. Ah, there we go. That's the figure we need. And then we should have neighbor edges. There they are. So, okay. All we need to do now is calculate which edge we're overlapping. So what I need to do realistically here is just sanity check this and make sure that it kind of does what it expects. So I think it's the second index is going to be the neighbor edge that we want to write. There we go. Okay, that should be right. I think that's gonna be right. I'm gonna have to look at the data and see if we can spot an obvious, maybe like put in a slightly simpler nav mesh and see if we can verify that it's definitely doing what it should be. So there should be a bit in here where it's, yeah, there it is. We need to make it so it outputs a constant rather than -1. Yeah, do this basically. Oh yeah, it's also oops, it's not a float. Ah, that could have ended badly. Okay, let's press build and see what happens. Oh, I saw errors. Let's do another build and see if we can see where they are. Yep, that'll do it. Spelled it completely wrong, that'll do it. And this is saying, I think this is when I'm looping, but yeah, I'm not passing all the arguments in. Okay. And we need to pass the neighbor edges of all the neighbor faces. And pull those out at the same time. Okay, I'm gonna have to rewrite what's going into this function because I've changed all the arguments. I don't remember where they all go. So vertex counts. Yep, and then neighbor faces. Yep, and then neighbor edges. Then edge midpoint distances, and then best distances. And then the face will be crossing into. And then we need to calculate the edge, which will be origin neighbor edges. And we use our edge to figure out what their edge is. Yep. And then destination face isn't going to change. It's still where we're trying to head. And then distance is the center distances based on the edge that we're crossing. Okay, that's nearly right. What's this saying here? What do you mean it doesn't? It absolutely does. See, it's right there. Oh no. It's definitely fine. Fine, I'll deal with you later, IDE. Okay, vertex count is going to be the same. Neighbor faces is going to be the same. Neighbor edges is going to be the same. Edge midpoint distances, we're basically all just passing all this through. Best distances, yep, that's going to be the same. And we're going to use the next face, and we're going to use the neighbor edges of the Oh, I should probably actually cache this look up here. And then we've got a destination face, which doesn't change. And we've got a distance, which is the distance we've taken plus the midpoint distance to the next edge. There we go. What do you mean? Oh, wait. That needs to be face hash midpoint distances. There we go. So what do you mean is an arithmetic type? Okay, let's build that, see where it ends up. It didn't like that. Oh yeah, I think that's right. I think I got rid of the arguments to tell it exactly where in 3D space. Because we're only dealing with kind of like we're only dealing with sort of edge numbers now. Okay, so okay, so we've got no root, do nothing. Otherwise, let's do something really dumb that'll work in this situation, but isn't a good idea generally, which is we're basically just going to use the edge normal and move in that direction. So, hang on a second here. Take out nav mesh. Take its exit normals. Take the face number, which is going to be the it's going to be that static nav mesh face, and then the navigation result, which is going to be the edge number we need to cross, multiplied by 3 because it's 3 axes. I'm going to move nice and slowly so we can see what's going on. 3 axes, and then we're going to write that to the next. Okay. This will probably slam into walls and things, but it should kind of work. Let's find out. Oh, wait. I just realized I didn't actually, I didn't do that right. I need to add the previous position to the direction in which we're traveling. Yep. And then so that's the next. Otherwise, it was going to jump all the way back to 0, 0, 0. We don't want that. Okay, is that going to build? How about that? Nope. Wait, what's going on here? What's going on here? Oh, that looks like it's building. Much like the tension. Oh, no, I saw errors. Damn it. What we got? I'm using the wrong type for this. But this is our opportunity to actually have a bit of a look at the data and see if we can figure out what's going on. So, yeah, I'm going to temporarily simplify this like a lot. And then export it. This is going to give us two polygons, which should be sharing a single edge. So let's do that. Let's build it. Well, that doesn't look right. I'm pretty sure it's not like 20,000. That doesn't seem right at all. I'm pretty sure neither of those two polygons has 20,000 edges. So let's see if we can sort that out. So Where's our neighbor edging? Where's our neighbor edge variable? Where is it? Neighbor edges. Ah! I wasn't actually writing the edge number, I was writing where we found it in the array. Oops. That's still not right. It didn't like say crush and rust of it. No. Ah. Why is that still like 2090? Okay, the next thing we need to check out is we're pulling this out of here. Where are we assigning these? Let's put a number in there like 123 and just make sure that it's coming out kind of correct. Oh, it doesn't like that. Okay. Oh, I think it should actually be that one. There we go. Right, so we've got those look rational. Let's have a bit of a look at them and see what's going on. So we've got two four-sided polygons, and so if I then grab the right, this is saying, you know, edge 2, so 0, 1, 2. This is saying 3, so 0, 1, 2, 3. That works. Okay, so next up we need to fix the broken code generation. I know where that is. If I come down to here, it's the neighbor edge remappings. Just using the wrong type for it. Come on, build. You can do it. Oh, it didn't like something. What doesn't it like? Let's just, I always like to grab these out and then just compare them side by side so the differences become obvious. Ah. What's this saying? Oh, hang on. That problem might actually be in here. Maybe I just, nope, that's correct. What is this on about? Oh, I know what it's on about. I know what it's on about. The bit where I actually assemble it into a struct at the end, I never actually added it to there, so we've ended up basically like shuffling everything else in the struct like down one item. Let's fix that now. So it's going to be the footer of navigation. God, so much stuff gets output. Where is it? Where is it? There it is. That's the one. We'll duplicate that. And now this might actually build. Come on, build. Okay, let's see what it does in the engine. I'm expecting a crash. Oh yeah, I never put the other tiles back in. That's interesting. Why is it trying to move in a... Oh, oh wait, I guess that's technically considered to be in that tile because it's in the closest tile. Okay, right. Let's put all the tiles back in. Let's do a build, watch it crash. Well, it's doing nothing, which implies it didn't find a route. So... And it kind of should have done, really. Either that, or I'm moving it so slowly you can't see it. That's also a possibility. Let's try speeding it up quite a lot. Nope, it's not that. Okay, so is it this? Is it going down here? Yep, it's going down that route. It's not finding a route. So let's try and figure out why that is. So is it hitting this? Is it actually finding any route at all? That's patently untrue, compiler, and you know it. Sorry. It's like, it's initialized. It's like, no it isn't. The program exits if it's initialized. Let's put this back in. See if we can just turn off that error. Just temporarily. So I think I've got warnings set to errors. Let's turn all the warnings off because... Well, that's actually the wrong... Let's turn all warnings and errors off just so we can get it, well, as many as we can off, just so we can see what it actually does. Come on. You can do it. Build. Okay, so we know that it's never hitting this branch because it'd be throwing an error. So something in here is failing to find a route. So we're coming into here and let's see if we can find our next option. Is it going to be this? You know, are we considering an edge at all? Yeah, okay, so we're getting that far. Are we getting to here? Now this would be where a debugger would actually be really handy. So we're never getting to here. Why are we never getting to here? Because if the best distance is not a number, which it will initially be, or the best distance is shorter, let's temporarily remove that. Didn't think that'd make a difference. Okay. So that should be iterating over the whole thing and finding where we need to go. Now there's going to be a bug in here that's incredibly subtle. And I mean, like obscenely subtle. That to do can go, we've solved that. There's going to be something in here that's just so ridiculously subtle. Something I've messed up somewhere. So yeah, get that rebuilding with the correct errors turned back on. Given we've narrowed it down to almost certainly somewhere in here. Yes, we're going over the edges. We've got the number of edges from the number of vertices in the count. Sorry, number of vertices in the face. We've then taken the edge midpoint distances and yeah, that's fine. That's good. Wait. Oh no, this is so dumb. I never use this. I never check if we've reached our destination. Oh no. So if we reach our destination, then return the distance we took because... Oh, no, wait, there's one more thing we need to do. We actually need to branch differently here. Yeah, because we need to actually use the center distance to know if... because it's possible, it's entirely possible that we, like, say, have a long face like this, right? And we're entering from like an edge like this. And we'd probably favor an edge like this because it's more likely to be close to the center. Okay, so I need to also pass in the edge center distances. Let's do that. Hang on. Yeah, I think it's called that, right? Let's just check. Edge midpoint center distances. There we go. And once more down here. Okay. Next step is, we detect that special case where the face is the destination face. Put that into an else if. I like else ifs. Not many people like them, I like them. I think the reason I like them is they're kind of like guards in Haskell, you know? It's kind of like, you basically just read from sort of top to bottom and you go like, right, if this, nope. Oh, it must be that then. A lot of people don't like them. I like them. Yeah, if it's our destination phase, then we need to add the center distances. Okay, that's good. And only then, if we're closer. Okay. Oh, it didn't like that. It did not like that. Because I didn't tell it what type of variable it was. C is not a language of type inference. It would be nice if it was. I need to make a variable for that. That's fair. That's fine. Yep. Okay, let's try building that. See where we end up. Come on. Come on. Oh, it's moving. It's going the wrong way, but it is moving. Where is it going? How mysterious. Wait, I think that might have actually been right. Sort of. Yes, okay, this is actually right. So, the thing I mentioned earlier where the behavior I'm putting in is a bit of a hack. Well, it's just basically like trying to cross this edge, but it's kind of not anywhere near it. So it's going to here, and it's going to walk along the bottom of here. It's kind of fine. And then it's going to go straight up. And then it's going to bounce backwards and forwards between these two faces because neither, going north to this one gets you into here, going south. Right, so next thing we need to do, really simple. Because I've got this kind of like, hacky kind of script here where we're basically trying to figure out, the the direction to travel in. And we want to change this up a bit, as it's a bit too simple. Let's make it detect the distance to the... Let's make it calculate the midpoint of the edge we're going to be crossing, and then move towards it. And if we're within so many, like maybe say a centimeter, just try and walk across it. So and it should be dead simple. I always say it should be dead simple, it never is. Navigation mesh and specifications, and then let me to wrap that around if it's the final edge. But that was actually really promising. That actually looked like it was working, which is honestly shocking to me. Oh no. Navigation results. That's good. Yep. So the second is going to be there. Why is it saying that's... Oh, okay. I think it'll let me do this. Yeah, it'll let me do that. It's trying to make it like an array, which is weird because you can pass like a pointer to a function argument with an array thing on it. Array syntax is weird in C. Like it doesn't like array types are kind of weird. They don't work how you'd expect them to. So let's just do some dirty hacks in here. Calculate the midpoints. And then we're going to do a very simple distance calculation between the previous point and the midpoint of 3 axes. And if it's over 0.1, bearing in mind it's a square, so that's actually going to end up being hit really fast. Then we're going to move towards it, just kind of like, where's the bit where it kind of, there. But rather than using the target, we instead go to the midpoint. That should make it follow the edges. Or it'll crash. My money's on crash. Okay. Let me speed that up a bit. That's a bit too slow. Want some fireworks, damn it. Okay. So yeah, it will slow down because of that hack we're doing to make it move. Okay, and then it's following the edges. Oh, this is actually working. Oh my goodness. Okay, and then it should stop there. And then it should keep moving that way until it gets line of sight, and it'll move in a straight line. It actually works, everyone. My God, we're actually navigating using the nav mesh. I'm going to speed it up a bit just for the sake of kind of like, well, probably just for having something to post on Twitter, but my God, it actually works. I can scarcely believe it. I'm going to speed that up again. Let's go like say 5 times that, and let's go 5 times that. Well, I'm happy with that. Let's commit these changes. And the good news is it's in a different project that's sadly kind of like tied to some person identifying stuff I can't really show. It's the I managed to get the inverse projection matrix and stuff working. Yeah, my brute force approach did eventually pay off. Where so I basically want to be able to if I like place a camera in the world, right? I basically want to be able to recreate the matrix this thing creates. So the way I'm doing that, if I open the Python console, is I think it's bpy.context.selectedObjects0. Yeah, we'll get you kind of like the camera data. And from there, you can actually get the, I think it's, can we just call the model matrix? What's it called? Matrix? It's called something. And you can actually get the matrices out. So basically, I set up a bunch of like test cameras, extracted all the matrices, and then basically just had a really terrible bit of JavaScript, like brute force formulae, until it found a calculation that produces the same outputs as Blender given the same inputs. And I just kind of sanity checked it, hand optimized it a few times. And yeah, it seems to be working, it seems to be passing all the tests anyway, so I'm happy with that. So next time I'll probably be introducing that, and then we can start moving towards actually being able to click on the screen and have things happen. We might get the protagonist walking to where you can stand by the end of this kind of like 60-day marathon thing. Okay, implement navigation. What else can I really say other than that? Well, it's like 2 or 3 minutes early, but I think that'll do, as I've kind of accomplished everything I set out to accomplish. Thank you for watching, and have a great evening.